Hello everyone. After we learned about dot product, now we want to learn about another type of multiplication of vectors. This one is called scalar product. And in order to distinguish that in comparison with the dot product, we don't use the dot symbol for the multiplication. So we say A cross B. That is the notation we always use for the cross product of two vectors, okay? Another name for cross product is vector product, okay? And the reason why we say so is similar to what we had before. The dot product was always a scalar. The dot product of two vectors was always a number, and that's why we called it scalar product sometimes. Now, cross product is also known as a vector product because the outcome this time is not a scalar. It is a vector itself. So if it is a vector, obviously it has to have a magnitude and it has to have a direction, and we have to identify both of them. In terms of its magnitude, the magnitude of cross product of two vectors is defined as the magnitude of the first vector times the magnitude of the second vector times the sine of the angle in between. So this time it's not cosine, it is sine. And that is the magnitude of this cross product vector. And if you want to know about the direction of this cross product vector, well, the direction of the cross product vector is perpendicular to both vectors A and B. If you have two vectors, vector A and vector B, and they're making an angle of theta with respect to one another, the direction of the cross product vector is perpendicular to both of them, and it is determined by the right-hand rule. But what is this right-hand rule? So whenever you want to find A cross B, this is what you do. You hold your right hand, not the left hand, the right hand, and the four fingers must be in the direction of vector A, as you clearly see here, okay? And then the way that you bend your four fingers inside, it has to be towards B. So right now I'm bending my four fingers, as you see, from A to B, and the direction of the thumb shows the direction of the cross product vector, okay? Now, if I want to find B cross A, all right, then I have to keep my hand such that the four fingers will point towards vector B, so as it is, but then I cannot bend my fingers back towards A, right? Can anybody bend their four fingers backwards? No. So what should I do? I have to kind of rotate my hand like this so that I can easily bend, the four fingers. So right now, my hand, right hand, not left hand, is in the direction of vector B, and I can bend the four fingers inside towards vector A, right? So when I hold my hand like this, I know that I have kept it in the correct position. Now, the direction of the thumb, as you see, it's pointing downwards, which means that B cross A would be a vector which would be pointing downwards. So right now, A cross B is upwards, but B cross A is downwards. So this direction would be the direction of B cross A. But right now I'm showing A cross B. So that's the direction which is determined by the right-hand rule, and the magnitude is clearly found by the definition at the top. Now you clearly see that A cross B and B cross A are not the same. Like magnitude-wise, of course they are the same. So don't look at this diagram. These two vectors must be drawn the same size. I didn't have room here. But in terms of direction, one is opposite the other. And that tells you that unlike dot product, cross product of two vectors is never commutative. So A cross B is equal to negative B cross A. So you can't interchange them. You know that A dot B is the same as B dot A. But in case of cross product, A cross B is not the same as B cross A. And also, if you find the cross product of any vector with itself, it would be the magnitude of vector times magnitude of vector itself. But then sine of 0 is 0, isn't it? because like any given vector makes an angle of 0 with itself. Therefore, the cross product of any vector with itself is going to be always 0. But it has to be 0 vector, right? Because cross product is a vector. And we have this distributive property that is valid. So A cross B plus C would be A cross B, which is a vector, and then A cross C. It's called the distributive property. And then if you have a scalar times a vector and then cross another vector, of course it's associative. You can put the K outside and find the cross product first, multiply that vector by this scalar. Or you can say A cross K times that vector B. Of course, we know that K is a constant or scalar here. So if two vectors are parallel, okay, if they're parallel, they're making an angle of 0 degrees. We said that sine of 0 is 0, therefore their cross product is going to be 0. But if they're perpendicular, you remember that the dot product of two perpendicular vectors was 0. But in case of cross product, sine of 90 is equal to 1, and the answer would be magnitude of A times magnitude of B, basically. And that's the magnitude of the vector, and the direction is of course found by using the right hand rule. Okay, so that's the story of cross product. And the cross product of two vectors has another form, and that other form is the Cartesian form of it, which I'll take the liberty to explain it. So if you have a vector A with components of A1, A2, A3, and if you have vector B, I don't know why I put B3. So A1, A2, A3, okay, and B1, B2, B3, then in that case, A cross B is found by a giant formula, believe it or not. Now this giant formula is A2B3 minus A3B2, then A3B1 minus A1B3, and A1B2 minus A2B1. So that is the formula for the cross product of two vectors given vectors A and B in Cartesian form. A1, A2, A3, B1, B2, B3 are just numbers, and these are all numbers end of the day. So that will be the answer. Where this formula is coming from, the proof is in the textbook, and it takes half an hour just to prove the formula. And for now, we are going to skip that. But in the textbook, you will find the proof. I suggest you just go over it and just read it once to see where this formula is derived. And then there is another thing. There's shortcut methods that we can use to find the cross product of two vectors. And I'm going to explain them in a separate session, after this one. Okay. So properties of cross product, definition of cross product, direction of cross product, how we find it, the right hand rule. For now, this much for the cross product. Thank you.